Hello everyone, welcome to textmastudy.com. Let's solve a problem based on first theorem of Castigliano. The question is, the figure that is given in the question shows a semicircular bracket ACB of radius r and fixed at A. A rigid horizontal arm BO of length r is attached at B. The bracket carries a vertical load P at O. Determine the vertical deflection of the load. This is the semicircular bracket ACB that is given in the question. The radius of the semicircle is r and this BO is a horizontal arm that is attached to the point B whose length is equal to the radius of the semicircle. Now here this is the point load P that is given in the question, which is applied at point O. Now let's solve the problem. This is same semicircular bracket that is given in the question. Now before solving the problem, let me draw this perpendicular line at point O. Now the length of the horizontal arm BO is r. And this length XO, whose length is r, it is inclined to BO at the angle theta. Now the value over here is r cos theta. The value here we get is r sin theta. So here the value we will get is total length r minus r cos theta. So the length at this portion will be r minus r cos theta. So now let's calculate the moment. Here the load P is given, so the moment will be P into R, and the moment will act here and pass on to this point B. So the moment will get PR, and that will be in anti-clockwise direction, PR. Now this load at O will shift to point B here. Now the moment at point B we will get is P into this effective length, that is r minus r cos theta. So let's take the anti-clockwise moment as positive. So here we got PR. Now this point load P from O got passed to point B. Here the moment we will get is P into effective length, that is PR minus r cos theta. Here we took PR anti-clockwise direction as positive, so we have to take this clockwise moment P into r minus r cos theta as negative. So let's open the bracket. We will get PR minus PR minus plus PR cos theta. This plus PR minus PR got cancelled. Now we got PR cos theta. Now let's calculate the strain energy, that is Wi. The value of strain energy is integration of moment square into ds upon 2EI. In place of moment we will write PR cos theta. PR cos theta whole square. In place of ds we will write r d theta, because let's take a right angle ABC, and here let's take a length whose value is r and it is inclined at d theta angle to BC. Now the value we will get is r cos d theta, and here the value we will get is r sin d theta. Now the value of cos d theta is very small, so we can write r d theta, and here the sin d theta value is very small, so we can write r d theta. So that's why in the place of ds we wrote r d theta upon 2EI. Integration from 0 to pi. Before proceeding the integration, let's take this PR and 2EI term outside the integration. So here the value will be P square R square into R, that is R cube upon 2EI, and integration from 0 to pi. What we left with is cos square d theta. Now let's replace this pi with pi by 2, and when we convert from 0 to pi by 2, we have to multiply a 2 onto the integration. So we get this into 2 integration from 0 to pi by 2 cos square theta d theta. Now here 2 got cancelled out, and what we left with is p square r cube upon EI, integration of cos square theta d theta 0 to pi by 2. In place of cos square theta, we can write cos 2 theta plus 1 upon 2 d theta. Let's take this 2 outside the integration. We will get p square r cube upon 2EI, and let's divide the terms. We will get integration of cos 2 theta d theta, limit from 0 to pi by 2, plus here 1 into d theta, integration from 0 to pi by 2. Integration of cos 2 theta will be sin 2 theta upon 2, limit from 0 to pi by 2. Here the integration of d theta is theta, limit from 0 to pi by 2. Let's take this 2 outside the bracket, and we will left with a sin 2 theta. In place of theta, let's put the limit 2 into pi by 2 minus sin 0, plus in place of theta, let's put the limit pi by 2 minus 0. Here 2 got cancelled. We will get only sin pi minus sin 0. Pi by 2 minus 0 is pi by 2. The value of sin pi is 0, value of sin 0 is also 0. So this term got cancelled out because the value we got is 0. Now we left with only pi by 2 inside the bracket. So the value we will get is p square r cube into 2EI into pi by 2. The value of strain energy we got is p square r cube pi upon 4EI. Now let's calculate the vertical deflection. The formula of vertical deflection is partial derivative of strain energy. The formula is del Wi upon del P. So by partially differentiating it, we got 2p r cube pi upon 4EI. 4 got cancelled by 2. Now we got the vertical deflection as p r cube pi upon 2EI. This is the answer. Thank you.